Now, yesterday we were dealing, and we still are dealing, with the inverse function. And this says, in problems 43 through 48, the graph of a one-to-one function is given. Remember, one-to-one function, it only passes the vertical line test, which makes it a function, but it passes the horizontal line test. That makes it a one-to-one function. Draw the graph of the inverse. Now remember what the inverse function does. If I look at the domain and I look at the range, so the function takes the domain to the range. So x goes to y. The inverse brings y back to x. In other words, it completes the circle. So that says if this is a graph of f of x, so the coordinate points are -2, -2, 0, -1, 1, 0, 2, 1/2. So that says that if x equals 2, y equals -2. 2 goes to -2, 0 goes to -1, 1 goes to 0, 2 goes to 1/2. That means if I wanted to graph f inverse of x, what would I need to do? If I want to graph the inverse, what would I have to do? I have to flip x and y. So that says if 2 goes to -2, then -2 has to return to -2. If 0 goes to -1, then -1 has to return to 0. If 1 goes to 0, then 0 needs to return to 1. And if 2 goes to 1/2, then 1/2 needs to return to 2. And that's what would give you the inverse, the coordinate points for the inverse. So -2, -2, -1, 0, 0, 1, and 1/2, 2. And if I just connect the dots, just do a dot to dot, this is what the graph of f inverse of x would look like. It's symmetric with respect to the line x equal y. So if you notice, there is a fold line, and the inverse function, if you were to fold along x equal y, this function would be on top of the original. They're mirror images of each other across the line x equal y. So there's a symmetry across x equal y. So you're looking at the function and its inverse.